So one of the main objectives in mathematics is to find relation between two quantities. So if we take two quantities, let's say y and x, and we need to make certain mathematical formulations to make a relation between them. So for example, let's say y is directly proportional to x. So if we replace the proportionality, we get y is equal to kx plus c. That means we have replaced the proportionality with an equal to sign and a proportionality constant. Now this y is equal to kx plus c is actually an equation of a straight line. And we can generalize this in two coordinate system by writing ax plus by plus c. This is the general equation of a linear equation for a two-dimensional system. And we can plot this on a Cartesian coordinate or by taking the values of x and taking the values of y and plotting it on the Cartesian system. So as you can see, I have taken y is equal to 3x minus 8 and y is equal to 2x minus 4 as two linear equations. So what we find out peculiar about this too is that these two lines intersect at a certain point, that is 4, 4. And in fact, this tells you that this is actually a unique solution to these two equations. And these two are known as pair of linear equations. These two lines represent the pair of linear equations, and when we solve it by plugging in the values of 4, 4 in any one of the equations, we see that it satisfies the equation. So similarly, we can take two general pair of straight lines and we can find out what is the relation between them. Do they intersect? Are they parallel to each other? Or are they the same lines? So there's a very easy way to find this out. And the way to find it is by taking the coefficients a1, b1, c1 and a2, b2, c2, which are nothing but real numbers. So now once we take the ratios of them, we find out certain values to it. So for example, I have taken a pair of line that is 5x minus 4y plus 10 equals 0 and 7x plus 6y minus 9 equals 0. Then I tend to find the ratio between them. The ratio between the coefficients. So that is a1 by a2, b1 by b2 and c1 by c2. And once we figure out that the ratios of a1 over a2 and b1 over b2 are not equal, then that means the lines are intersecting. So every time we keep on doing this, we tend to find ratios between a1 and a2, b1 and b2 and c1 and c2. That is the ratios of the variables x. So the coefficient ratios of the variable x, y and your constant c. So when we plot this, we find out that it intersects at a certain point. So this tells you that these two equations, these two linear equations or this pair of linear equations have a unique solution. Similarly, if we take another pair of linear equation, if our ratios of a1 over a2, b1 over b2 and c1 over c2 are equal, then this line is actually the same line and we call it as the coincident line. And there are infinite possibilities because it's just the same line. So you can take as many number of x and y values you want and you can plot it on a coordinate axis. Okay. Then at the last part, we see how the lines are parallel. Only when your a1 over a2 and b1 over b2 is equal, but not the c1 over c2. So only when the ratios of a1 over a2 and b1 over b2 are equal, we find out that these two lines are in fact parallel to each other. So you see that x plus 2y minus 4 and 2x plus 4y minus 12 equals 0 are parallel to each other. So these two lines do not have any solution. Now, why is this important? So this kind of linear equations are something that we'd call as optimization problems if these two lines intersect. So what we can do is we can take Newton's kinematical equation and we can write v is equal to v naught plus at, where v naught represents the initial velocity and a is the acceleration and t is the time. So let's say there's a car 1 that has an initial velocity of 3 meter per second and an acceleration of 1 meter per second square. And there's another car 2 that has an initial velocity of 15 meter per second, but it is decelerating with 3 meter per second square. So we can make the equation of both of them, and the equation is governed by these two, equation 1 and equation 2. So what we can do is we can solve this algebraically and we can find out at what point of time do these velocities become equal, because one of them is decelerating and the other one is accelerating. So naturally both of them will have a certain amount point where these velocities will be equal. So we tend to solve this, and when we solve this algebraically by subtracting equation 1 from 2, we find out that our time t is equal 0. You can pause the video and you can find out the amount of time. So once we substitute the value of time t is equal to 3 seconds, we get v is equal to 6 meter per second. So at exactly 3 seconds, we will get that your velocities of these two cars will be equal. Now such kind of things are really useful in physics, where we want to find out for any two given systems a common value. So this is how pair of linear equations helps us to understand certain patterns or certain phenomena in day-to-day life.